Hi, good afternoon all. I guess I'm audible. Yeah, thank you. So we have had very diverse sessions in the morning. Like both the panel discussions were completely diverse in nature. Now I'll be picking up a few things from both the presentations. We'll be talking about how innovation, how disruption, and using that technology, how we'll be able to, have a sustainable operations. This topic, this session in this next 15 minutes, which I have been told, is about unlocking productivity. Productivity, when defined in its simplest terms, is like, output by input. So in order to, I would say, increase the productivity, simply we have to sort of increase the output. It's as simple as that. But then, if we now look at the studies from ARC, what ARC says is globally, 5% of global productions is lost to unplanned shutdowns. And that in terms of value is like $20 billion. And this is avoidable. And like out of this $20 billion, around 80% is something which is, which is sort of an avoidable downtime. 42% of it is because of human errors or manual errors. How can this be prevented? The whole idea is that when you talk about productivity, it's about an operator operating the plant safely and profitably, so that the operation margins are protected. Now, the most important person in a process operation is the operator. What we are going to look at now in this, topic is how an alert operator, how can focus operations help the organization unlock values in terms of productivity. These are some numbers which we have: 50,000, 150, and 1. Like any guesses on what these numbers relate to? These numbers are definitely related to the process operations. What we have here is we have a process unit of more than 50,000 hardwired IOs. It has very complex batch operations. There are multiple third-party devices, and when we put those third-party devices into context, this number certainly becomes nearly 100,000, 1 lakh. Then we have 150 equipments, complex batch processes. Then it has critical safety and production interlocks. All of this is being operated by a single process operator. Is this a sort of futuristic or is it reality? Next 10 to 12 minutes we are going to spend on this as to how with innovation, how with disruption of our thoughts, of the way we have been doing things, how we have been able to achieve this. Digital twin, I think like in the previous session we had a topic about digital twin. What we have here on the screen is a motor. This can be any other device or any other equipment from the plant. The point here that we have is that sort of every equipment or asset in the plant will have various aspects. Let's call a motor as an object. So this motor will have various aspects which will be depending on the person who is looking at it. A mechanical person would have sort of different sort of aspects for it. Similarly, an instrumentation process operations will have different aspects to it. But eventually, when we look at in the overall plan, overall systems, the operator should be having all the aspects of a given object available on the fingertips. This is what it changes. Now is what we have is a real game changer, is an unique aspect object concept. We have a transmitter here. So there are various aspects associated with it. It can be a simple faceplate, or it can be a live video feed, or it can be a data sheet, or an SOP, or a process manual, or PNID. Depending on who is using it, the requirements of a particular user would change. What we have is a single click view for operations and similar single click view for people from maintenance. It can be from electrical, it can be from automation, it can be from sort of engineering as well. Now, what we have here is in a one view, in a single view, a plant operator will be able to have a look on the CCTV feed, the overall displays, the graphics, the faceplates, the alarms, the trends, and the SOPs or the manuals or the documents. So practically everything is there with the person on the fingertips. Now let's look at how the HMI has evolved. This was one when you look at doing more with less, the first topic that we saw was digital twin aspect object technology. Second part, what we are moving towards is how the HMIs, the way we have been looking or operating plants, have changed over a period of time. There was a time that where we were actually looking at reproducing just the PNIDs and having a very colorful graphics. From there we moved to 3-dimensionals. From there onwards then we moved to slightly more lesser ones. Today what we have is a high performance graphics wherein only the process flow is being documented here or is being shown here. It is less colorful. It is made in a way that an operator's attention would be focused on a place where he or she has to take an action. An operator should not be bogged down from a host or a flood of information, which would then lead to the operator getting confused and it eventually leading to a sort of the operator not being able to take the right decision at the right time. So we have actually moved from a very graphical representation to a representation which is fully operator centric, which allows the operator to really focus on where the operator has to take action. So because a focus operator will be more alert, will ensure that the plant is operated very safely, and that in turn will ensure that we have a higher uptime and the process is always in a safe zone. Point number 1 was the digital twin. Point number 2 was high performance graphic. Now we move on to the point number 3. Mr. Shriram did say that in the morning that it is very important that we have young talent to be attracted to the plants or to the processes. That's a fact. It is really becoming a challenge today to have young talent working in shifts, working in the plant. And it is very important that the plant ergonomics, the control room ergonomics is designed such that people are actually attracted to come to work. So what we have as a third aspect here is an extended operator workplace, which is a solution which is ergonomically designed, keeping human factors and eyesight, the height and all of that. So a person can work standing, a person can work sitting. Depending on an individual preference, a person can come and tap and the entire setup will get aligned to that person's preferences. It has a very, very high level of situational awareness. It has and the alarms, the events will be directed to only the person is there. So in all, the plant visualization has been it has been revolutionized. This is one of the ways that how it's a disrupted way how exactly the plant operations were made earlier and are being made today. In earlier days, we would have a big panel, large screens, Today, everything gets consolidated. This helps an operator to focus only on the areas where the action is required. Even the CCTV feed, the PS systems, everything is integrated into one place. So the first thing was the aspect object technology. Second thing was high performance graphics. And the third point was extended operator workplace. All of these three, now when combined with exception-based operations, helps us achieve one plant, one operator. What happens here now is the most interesting part for all the people who are there into the plant or who are responsible for running the production. We have a screen here wherein only the alarms will keep appearing. An operator has to look at the alarm. Click on the alarm will take the operator to a respective set of views, take action and come back on this. So an operator really does not have to look at lot of graphics, lot of trends, lot of faceplates. Only look at this one screen. As and when an alarm appears, click on the alarm, navigate to the next page, take actions, come back here. With this concept, and there are libraries available with which this system can be, this system or this function is made available. So what an operator does is, the operator will always be focused only on one screen. Whenever there is a relevant action to be taken, that operator, he or she would go there, take an action, come back, and there will be no duplication of alarms. If there is one alarm appearing, that alarm would be a superset of all subsequent alarms. So it's not that there are multiple alarms appearing and a person has to keep juggling. There will be priorities will be defined for all the alarms. So the high priority alarms will have to be acted upon first, and so on and so forth. And the system will also give an advisory that on such and such alarm, these are the actions that need to be taken. There will be an SOP which will be shown. How it does it is like this. This is a typical view. This is a high performance graphics that we have here. All the alarms are segregated. On an alarm, let's say from the previous screen, if an operator has clicked, the operator would come to this screen. There would be a graphic, there would be a trend, there would be a faceplate, there would be a manual. So an operator would exactly know what is to be done, does that action, and comes back. So with this, actually we are able to do more with less. And it is not a concept. This is in existence since 2018. There are systems, units which are running on this concept. A large chemical units, large specialty chemical units with like sort of 50,000 IOs. 50,000 IOs is really big. With 50,000 IOs are being run by a single operator. So all of that operator has a complete view of all the systems of the plant. And with this exception-based operations, it is possible that one operator controls 50,000 or monitors and controls 50,000 IOs, more than 150 equipments with ease, with complete ease. So summarizing, how exception-based operations has actually revolutionized, or have actually, in a way, if you can say that this is the way how our thought process has been disrupted, because we don't need many screens, many operators, section-wise people doing jobs. You have one person who has a complete view. You make all the information available to that person. With high performance graphics, the person will have a good view of the complete process. The person will have, the person will have only the information that is necessary to be shown will be there. And the library elements which are there in the system, those library elements help design this system with ease. Those library elements make it very, very simple while configuration. It is not also configuration intensive. Use the library elements and the system is up and running for use. Help with aspect object technology and EOW. So all of this put together This is how the concept of one plant, one operator, which is now a reality and something something which has been adopted by more and more customers now. Should there be a need that you would want to understand more on this, you would want to hear from us on this, we have a stall out here. Me, like myself or any of my colleagues would be more than happy to share more knowledge, information around it. So please feel free to reach out to us. Finally, what we have is we had a look at one plant, one operator. Looking at the overall solution which we have, there is a solution that we have is that System 800 XA is our flagship product. Under that, plant electrification, process electrification, then process instrumentation, any third-party devices, safety devices, all of them can be integrated under one umbrella. This is what we call as one plant, one system. So please feel free to reach out to us. Please ask any questions or queries that you may have. We are right here. We are right here today and tomorrow. We will be more than happy to share more knowledge or more information around it. Thank you.